Hey guys, we're going to be learning today about the wind in the atmosphere. You're going to want to write down your learning target. So the learning target is you're going to be able to describe how the jet stream and the winds influence local weather. So today we'll probably focus a little bit more on definitions, and during the week we'll get more into how it will affect your weather. Okay, so just as a refresher, cold air is more dense. It will create a higher air pressure because remember all that dense air. So think of all those molecules pushed in together, creating that high pressure, and it will sink due to how dense it is. So in this picture, you'll see the cool air sinking. So cold air sinks. Your warm air is less dense, creates a lower pressure, and it will rise. And the reason why it creates a lower pressure, because remember your warm air kind of spreads out, like the molecules like thin out, and there's less pressure there because of that. And your hot air will rise. And again, hopefully this is a review of what we learned before break, but if not, here you go. So warm air, less dense, will rise. Air replaces itself and causes movement. When the warm air rises, the cold air will come in and replace it. And the reason why is because air always moves from a higher pressure to a lower pressure. So when it gets out the way, so kind of just like this cycle in our atmosphere, you'll see this a lot more when we get more into like extreme weather. But for now, just knowing that hot air rises and your cool air sinks and replaces it. So wind is the movement of air caused by the differences in air pressure. So when you look at the Earth, so here's your equator at 0 degrees. We'll spend a day and really look into the different degrees of the Earth. But when you're looking at this, you'll see that at 0 degrees you have a difference. So this one here is moving towards the west. Towards the east, it changes because of air pressure. And remember, it's always going from a higher to a low pressure system. So it's always kind of going towards that low pressure, high to low. You don't have to know specifically why it occurs, but we will go into the different trade winds. But yeah, you can see, so wind is always moving in different directions. Two reasons. One, because of pressure. Also due to the fact that the Earth is moving. It's round and we're moving. So that's another reason. Just as a reminder, your equator receives more direct sunlight than the poles. So some people may think, oh, the equator is just closer to the sun, when actually the equator is just more direct in its sunlight. And I will review that with you. I have a little like activity where I'll show you with a flashlight. Like if you've shown a flashlight directly on an object, it'll get all the direct sunlight. If you angle it a little bit, like for instance, the Earth is round, so it's angled up here, it gets like more of an array of it, of the sun. But you can see by this picture here, by the equator, it's a lot warmer. And the further away you get from the equator, the colder it gets, okay? Due to the fact that this area gets more direct sunlight. Okay, so we're going to start with the Coriolis effect. Due to the Earth's rotation, the wind moves in a curved path. So in this picture here, like you would think, like the wind is just moving up and down in a straight line, but it's not. And I'll show you a different demonstration. We'll actually do something with a balloon. But when it moves, when it's a circular and the Earth is moving, you're going to see that instead of it making a straight line, when the Earth moves, it makes a curved line. So all of our winds are moving east to west or west to east, depending on the pressure system. And that's called the Coriolis effect, the fact that it's curved instead of a straight line, because when the Earth is moving, when we're rotating in a circle, that line gets curved. Okay, so the trade winds. So there's different winds in the Earth, and we're going to go over there's three. The fourth one is kind of not really needed, but the first one is called the trade winds. So the trade winds, when you're looking at the Earth, remember this is the equator. It blows between 30 degrees. This is in both hemispheres. So this is your equator, this is the northern hemisphere, and this is the southern hemisphere. In your northern hemisphere and southern hemisphere is the same. So between 0 and 30 degrees, the wind is going to blow to the west. So it goes this way. So it's going to go either way. It's going to go, so down here, it's going to curve this way. And then the northern hemisphere is going to curve this way, but they're both going towards the west. Okay, so you'll recreate this one day this week, but from 0 to 30, that's your curve. Then you have your westerlies. So the westerlies blow from 30 degrees. So I don't have it on here, but this would be 0 to 30, 30 to 60. So from 30 to 60, your westerlies are blowing towards the east. It's called westerlies because it's coming from the west. So the westerlies, so this is between 30 and 60 degrees latitude in both hemispheres. So here and here, and it's going to blow towards the east. Okay. The last one's called your polarly easterlies. Again, it's going to happen both in the northern and southern hemispheres, and it's going to blow, and it's from the poles to 60 degrees, and it's going to go curve towards the west again. And the reason why they alternate is due to the pressure systems. That's just the way the pressure works. So another thing I forgot to say is it's called the trade winds because when Europe was traveling, they used those winds, and that's actually why they ended up in the New World. Okay, jet streams. So this is the last big thing that we're going to go into when it comes to different streams. And this is the reason why we had such a cold winter this year is due to this polar jet. But they're narrow belts of high winds that blow from west to east. So if you take a look, they're all blowing from the west to east. You have the polar jet and you have the subtropical jet. The polar jet should kind of reach through Wisconsin, but it's kind of starting to break due to the melting of the glaciers up here, and it's starting to move way more south. And that's why we saw some really cold winds down here, a really cold winter in this area. But yeah, in the winter, this is why it's cold. So basically, jet stream moves south, bringing the cold Arctic air to the United States. So usually, obviously, it's always cold up here, and then as it gets as winter comes, it moves south. A lot of scientists, like I said, think that what happened was with it, it keeps it maintained up here, but when the ice melts, it broke this and it moved it. Basically, they said the polar jet stream reached all the way through the middle of the state or the country, and that's why it was so cold this winter. Okay, the difference between weather and climate, because from here we're moving into weather and climate. So how does that affect weather? And we're going to get into weather moving on here, but weather is the condition, it's at that moment. So the weather is today. Like, what is it? Oh, it's sunny right now. So short-term variation in the atmosphere, the condition in the particular location at any given moment. The climate is more like the average over a period of time. So, you know, in 2016 to 2019, the weather has increasingly, temperature has increased due to climate change or whatever it is. So that's, that would be the difference. So weather is right then, perfect, and location right then, and climate is like the average over a long period of time. Okay, so that's it. Make sure you do the best in all your questions throughout, and that you have completed all of your guided notes. Some of you guys forget. Hopefully you didn't, because right now you'd be rewatching the video. Thank you very much.